Hi guys, welcome back to the channel. In this video we are going to discuss about asynchronous 2-bit counter. In the previous video we have already discussed about the intro for the counters and the type of counters. So asynchronous counter and synchronous counter are the two types of counters. So in this video we are just focusing on 2-bit counters so that our understanding will become more better on the counters. Let's get started. So if you observe, we are going to have the 2-bit asynchronous counter here. For that I am taking two JK flip-flops because it can store one flip-flop can store only one unit of or one bit of information. So as we are having 2 bits, I am going to take two flip-flops, that is two JK flip-flops. You can use D or T flip-flops also. So that implementation also we are going to see in this video only. First of all, we need to understand with the help of JK flip-flop. It is very important. So for the first condition, if you already know, we have already discussed about up counter and down counter. Up counter means it will going to start from 0, 1, 2, 3 and again going from 0, 1, 2, 3 like that. So down counter means 3, 2, 1, 0, 3, 2, 1, 0, it will go like that. So you can see the first one is LSB and the second flip flop is MSB and the clock. So as this is the asynchronous one, the previous output would be as clock to the next flip flop. So first of all, we are going to see with the negative edge triggering of the JK flip-flops. So you can see the truth table also over there. We have one output Q and second output Q naught. So as the MSB and LSB, that format I have wrote there. In the truth table also you can also observe there. From MSB is 0, LSB is 0, the first case. Next case is MSB is 0, LSB is 1. Like that it is changing from up to 1. So we can clearly understand this truth table with the help of the timing diagram analysis. So we will also see that in this video only. So as this is counting from 0 to 3, we have total 4 states. So we can call it as mod 4 counter also, or 2-bit ripple counter. So asynchronous counter is also known as ripple counter. It has two names, ripple or asynchronous, both are same. Remember, first we are saying with negative edge triggering. You are going to connect Q0 to the next clock. So in this, if you see, this is 3-bit ripple counter. In detail for this explanation we will going to see in the upcoming video. But remember this, we are going to have LSB in the right hand, left hand side, RSB in the right mode side, and you can represent in the truth table like that, Q2, Q1, Q0. And one more important thing, then you might get a doubt why we are passing JK both are equal, that is equal to 1. So first of all, you see this is the using JK flip flop. So in this video only we are going to see with the help of D and T also, but JK is very important. JK and D is very important for the implementation of any counters. So if you observe, JK flip flop output would be toggled when J is equals to K is equals to 1. So we already know about JK flip flop and its truth table. When both are equal only, the output will be toggled from previous state to the next state. So that is the reason we are taking that J is equal to K is equal to 1. And one more important thing here, it is negative negative edge triggering. So that I am taking from Q0 as a clock to the next, Q0 output as a clock to the next flip flop. Let's also understand with the timing diagram analysis. So this is the clock that I took some random thing. So as this is the negative edge triggering, so first we need to have two, as we have only two outputs for the first flip flop and second flip flop, that is Q0 and Q1. I am going to draw according to the first clock edge, means falling edge, because this is the negative edge triggering, right? So I first started with the Q0, next I will draw Q1. So if you consider Q0 for the falling edges, it will react. So if you see the first falling edge up to the next falling edge, it will be going to have high. Similarly, in the next falling edge, it will again going to have the rising and again it will go left. So I hope you know this. This is the basic Q0. Next thing that we have next input, that is Q1. So if you observe Q1's clock is Q0. So basically by seeing Q0 only we are going to draw the Q1, because for the Q0 what is clock? The main clock. For the Q1 we have what is clock? That is Q0. So by seeing Q0 we are going to draw Q1. So if you see the Q0 clock, that is falling clock edge, up to the next falling edge we are going to draw a clock pulse, high level. You can also observe that. So now we are going to understand the timing diagram analysis, or we are going to verify this timing diagram analysis is correct or not. So first of all, this is 2-bit up ripple counter. First we need to see the Q0 and Q1, it is 0 0. So you can also observe that is 0 0. 0 means binary, also 0 0 means what is in decimal, that is 0 only. So you can see I have started the series with the 0. So the next thing in the clock transition and the Q0 Q1, if you see that is 1, means Q0 is high, Q1 is low. What is meant by that? We are going to have MSB, LSB according to the truth table, that is we have to write Q1 first, Q0 next. So as that is, if you see 0 1, that is. So what is meant by 0 1 in decimal, that is 1. So you can say up counter I have updated with the 0 1 also. Again, if you consider the Q0 and Q1, you are going to represent Q1, Q0, right? So if you say Q0 is high, Q0 is low, Q1 is high. So you have to represent Q1, Q0 means 1, 0, that is 2 in decimal. So you can see I have updated the up counter as 2. And finally, if you consider the final case, that is Q0 and Q1 as both as 1, 1. So that is the in decimal, that is 3. So you can see also or verify in the truth table also. So likewise in every situation or every clock transitions, it will change like this only, Q0 and Q1. If you have more multiple flip-flops, then also you are going to have according to that 3, 3. It will change from, or it is known as up counter. It will basically count from 0 to 3. If it is 3 bit flip-flop, it will count from 0 to 7 like that. I hope you understood that up counter. So now we are going to understand 2-bit down asynchronous counter, a small change, that is down counter. So in the previous case, we have saw the feedback, or the clock that we have taken to the next flip flop is from Q0. But a small change here, that clock we are taking in the negative edge triggering is from Q0 bar. So this is known as asynchronous counter, but down counter. It will count downwards. Means if you have 3, 2, 1, 0 like that, it will count. So we can also understand from the timing diagram analysis also. So the clock I took the same thing, means the negative edge triggering clock. So if you observe Q0, first of all I took Q0. So according to the falling edges, the Q0 will be responding, that we already saw in that. So now we are going to have the Q0 bar for finding Q1. Why? For the output Q1, what is the clock you are going to see? So for the Q1, it will respond to the clock pulse. But what is the clock? That is Q0 bar, not Q0. So we are going to obtain the Q0 bar, and according to the Q0 bar, we are going to respond the Q1. So first of all, we need to find out the Q0 bar. As flip-flop responds to the clock. If you observe for the second flip-flop, the clock is Q0 bar, not Q0. But we have obtained the Q0 as previous we already saw. So just flip that Q0, we are going to obtain the Q0 bar. You can see that, just a flip that. Now we can have the negative edge triggering for the Q0 bar, and we can simply formulate the Q1, because rise means each edge, negative edge triggering will be triggered the Q1. Now we are going to obtain the Q1. If you see the first falling edge, there I have raised. If you see the next falling edge, that I have down. So like that, if you have the more big chain or means big pulse also, you can do that, because if you compare also in the truth table wise, it also works. So as we are having two outputs, that is Q0 and Q1, we are going to judge the output with the help of Q0 and Q1, not the Q0 bar. Just that is the clock for the next flip flop, that's it. But we are going to have ultimate outputs are what? That is Q0 and Q1. That is the thing that we are going to find or have with the help of 2-bit counter, right? So as is a down counter, we are expecting to start with 3. But in this, we are going to start with Q0 and Q1 as 0, 0. It's not a problem. If you see clearly, I have removed the Q0 bar, because that is not important necessary, because we are going to compare the Q0 and Q1 for the outputs. So first of all, if you consider both are 0, so next thing if you consider both are 1, so next thing if you consider both, that is 0, 1, so 1, 0, that is sorry. If you consider MSB and LSB, you can see in the truth table as well. So how the order is there. So it is starting from 0, it's not a problem. Next 3, next one 2, next one is 1, like that it will follow. You can see in the down counter sequence also, that is 0, 3 to 1, 0, 3 to 1, like that it will follow. But ultimately what? It is a down counting. Now I will say some trick or some adding some combinational circuit, so that it becomes our both of the thing at a time. We have saw up counting, we have saw down counting. So what if you have up and down in a single circuit? It's very important and easy, right? So we are going to see now that only. So if you observe, just add a 2x1 multiplexer in between and have select line as 0 or 1, that is your wish according to your requirement. So let's understand how to use this. And one more important thing, for the 2x1 multiplexer output, take output as a clock to the next flip flop, and take two inputs as Q0 and Q0 bar. First, suppose if you want to implement the up counting, then what you will do? Just you will take clock to Q0 as our clock to the next one. So that is the thing, right? Output of the first flip flop is taken, clock as to the next flip flop. So for that, in the 2x1 multiplexer, we are going to have 0 as select line. So 0 means it will be going to select the first one, that is Q0, it will select. So that is the required thing we want. So the first Q0 will be clocked to the next one. So this acts as a up counter. In the same way, if you want to implement the down counter in this only, you are going to pass the select line as 1. So if you are passing select line as 1, the line selected is Q0 bar. So it will be given as clock to the next flip flop. So I hope you know already how we can relate the previous one. So we have already seen that if Q naught bar is clocked to the next flip flop, that is our down counter in JK flip flop. So simply with the help of one select line, we can able to do all the things or up counting and down counting in a single asynchronous counter. And it is also again the asynchronous counter, because the previous output is given clock as to the next flip flop, and we have only 2 bits because we have only 2 flip flops, and we are performing up and down counting in a single thing with the help of a single combination circuit, that is multiplexer. So up to now what we have saw is with the help of the negative edge triggering. So if you want, again I'm saying, if you want to represent or perform with the help of positive edge triggering, or you have only the clock of positive edge triggering, then you can use this, or you can represent like this. So for the up counting, see that a definition or heading clearly, this is the up counter, 2-bit up counter using JK flip flop, that with the help of the positive edge triggering. So taking Q naught bar as the clock to the next flip flop, remaining all things would be the same. So this is 2-bit up ripple counter using JK flip flop, and taking Q naught bar as clock to the next one. So the same thing if you take in the negative edge triggering, that becomes a down counter. But as this is the up counter, we are taking, as we are having the positive edge triggering, we are going to take from Q naught bar as clock. So then you are going to have the down counter with the positive edge triggering in the JK flip flop. Then you need to just invert. You need to connect Q naught to that thing next flip flop, that is as clock. If you observe, this is exactly opposite when you are using the what we call that negative edge triggering. That is the simple thing that you can able to have some idea or some logic in your mind that you can represent or implement in your mind. Just start understanding with the help of negative edge triggering. Just invert both of the two cases that you can able to obtain the whole thing. So exactly opposite of the up counting in the what we say negative edge triggering. So these are the overview of all the things. So if you observe, the first two are with the help of negative edge triggering, the next two are with the help of positive edge triggering. So we understood in this video with the help of first negative edge triggering. If you understand with any of one of the thing, that you can remember the next thing also very simply. So just understand the negative edge triggering. So in the negative edge triggering, for the up counting, we are passing Q naught as clock to the next one. In the 2-bit down counting, we are passing Q naught bar. Just exactly opposite of this thing will be the in the positive edge triggering. For the up counting, we are passing Q naught bar. For the down counting, we are passing Q naught as clock to the next flip flop. So the change in clock, that's it. That is the main thing in this, the asynchronous counters and synchronous counters. The position of clock or the positive or negative edge triggering, that makes sense how the connection should be made. If you remember one thing, that the remaining things would be very easy. So I am saying always that we can also implement with the help of T flip flop and D flip flop also. Now we are going to understand the 2-bit up counting, asynchronous counter using the T flip flop. So as we are having the asynchronous 2-bit we are going to implement, I am going to take 2 T flip flops, and as it is up counter, we are going to take clear also. It is very simple. That clear means we already discussed in the previous video. We can connect, or means for the representation purpose we can connect here clear. We have to connect clear in the JK flip flops also, but for clarity or better understanding, in the circuit diagram I did not draw the clear inputs. So in the T flip flop, we are going to understand the main important point is that T flip flop output would be toggled when T is equals to 1. So that is the reason I have took the 2 T inputs as both as 1 1, and you are going to pass the for the second flip flop T flip flop clock as Q naught bar. That is the situation that you are going to have the 2-bit asynchronous up counting using T flip flop. In the same way, for using D flip flop also, we can construct the 2-bit asynchronous counter. So in this Q naught bar is equals to D. That is very important. We should not pass DD as 1 1. That is very important point. You can think we have to pass always inputs as 1, like that you can think. No, we have to check when the conditions would be toggling, or when the previous next clock would be toggled. That is the main situation you have to consider, and you need to pass the inputs. So if you have the inputs D, that is Q naught bar, that is we have to take feedback, because we already have Q naught bar, and for the next flip flop we are going to pass clock as Q naught bar only. Remaining all things would be the same, but the inputs are not 1, that is Q naught bar, and the clock for the next one is Q naught bar, and remaining things would be same. So this is 2-bit up asynchronous counter. You can pass the variables, means the zeros and ones, and you can check out the outputs Q naught and Q1. You can have the timing diagram analysis, truth table, and you can check all the remaining things. We already saw in the JK flip flop as well. So in this also up counting, down counting using T, D, anything is possible. But I hope you understood for JK. JK is very important. I hope you understood this video. In the upcoming video, we are going to discuss with the help of 3-bit, 4-bit also. So stay tuned. Thanks for watching up to now.